We are team 5, and title of our presentation is Estimating the Geothermal Potential of Heat Exchanger Anchors on a Cut and Cover Tunnel. Next slide. So, in this, we are considering alternative sources for the energy needs of heating and cooling of buildings. And this study demonstrated the geothermal potential of using cut and cover tunnel anchors as a heat exchanger. In this, we consider the influence of soil properties and water tables, and we optimization and comparison is done using finite element analysis.
So the geometry looked at was the cut and cover profile with the anchor pins and the walls that were used for construction of the tunnel. And Lagamine was the FEA code that was actually used to do the analysis of heat extraction, which you can see in the yellow arrows. And there was no mechanical behavior, strictly thermal behavior that was analyzed here. And of course, the soil had to be analyzed. And so there were two permeabilities compared with soil. It was the non-permeable, slightly permeable soil. And the constituents included the soil grains, the liquid and the gas between the soil grains. And two types of soils were analyzed: saturated, which was had a full saturation of water, and unsaturated soil, which had some air with the water. And this was determined by the water table level, which pushed water into the soil. The equations that governed the water was the conservation of mass equation, which we actually see the storage and the flow of water into the area. And we also see the energy balance equation, which also showed the storage and the flow of energy, as well as the heat generation within the soil property. And enthalpy was used as the storage mechanism, as well as calculation by heat, bulk heat capacity, which included the soil grains, the water, and the air. And we also had to connect the soil temperature and the pore water pressure to the governing equations. And so water density, water velocity, and heat conduction were calculated, as well as the soil thermal conductivity, which again showed the three constituents of soil, as well as the suction occurring because of the unsaturated soil and the degree of soil saturated needed for the mass conservation of water. And so the actual analysis was set up with boundary conditions on the mesh, and we could see that the far right or the far left of the boundary conditions included an impervious and adiabatic wall, and that was strictly because of the symmetry of the tunnel. And then we could see the impervious and fixed temperature of 284 Kelvin at the very bottom of the mesh, and pressure imposed by water on the far right, and the temperature of the soil itself was imposed on the very top. And so we could see that point 1 was the analysis point, where we can see what the actual temperature was and the heat extraction would be through the anchors. Heat flux multipliers were used to compare the load on the buildings, the heat load on the buildings, and how much actually was extracted and injected from the soil. Now, the results showed that there was a certain amount of heat that was actually able to be extracted during the cold months and injected during the summer months. And so a optimization multiplier was used on the heat flux multiplier. And this actually allowed analysis to be performed without letting the freezing of the soil occur, and a maximum of 4 watts per meter of energy to be extracted.
So heat output we got for per kilometer tunnel ranges from 0.4 to 0.8 gigawatt per year. And it's also found out that heat extraction strictly depends upon the hydrogeology of the soil. And as we can see, the heat extraction using anchors are less than if we consider geothermal piles. This is because anchor diameter is much smaller as compared to pile foundation. Next slide. So for future plan, we are looking to optimize the number and spacing between the pipe, and also to improve the thermal property of the grouting material for concrete grout. And we are also investigating for the water table changes during the summer month for heat injection part. Next slide. These are the references we used for this presentation. Thank you.